Hi everyone, in today's lecture we will look at the arithmetic operations in 8051. We will look at the most simplest and basic mathematical operation that can be or instruction that can be done in 8051. So we will look at today two instructions, add and add with carry. So before we proceed, we will look at what are the combination of add and add with carry instruction that we can have. We can have combination of add. So add basically is an instruction where you will add two numbers. It will use the ALU. When you use the ALU, the 8051 ALU is 8 bits. We can add two 8-bit number in a single instruction. When the ALU, always accumulator is used, one of the register will be the accumulator. So we have add A, comma. This second variant operand can be varied. First, this is hash. So you remember my addressing lecture, this is called as immediate. So you can have an immediate number, you can add an immediate number, and finally when you add some two operands, the final result, so A plus hash n, that is any operand, will be stored back in A. You have add A, comma Rn, where n can be 0 to 7, that is any registers. So it can be A plus Rn, result will be always stored in A. Add A, comma address, where A and the data within that address. So data within that address will be added and again it will be stored back in A. This is add A, comma at the rate Rp. So Rp, where P can be 0 or 1, and again the data A plus the data pointed to by Rp. Okay, so that will be added together and the data will be going to A. So basically what you can see is the final results always goes to A. Here now with respect to addition, there are two flags that are always used, that is the carry flag and the overflow flag. We have seen both this flag in the PSW register, right? So when is the carry flag? This carry flag is set when there is an overflow. So we will see both of this. So this is used with unsigned as well as signed addition. This is used when you are doing signed addition. Please go through the lectures for signed and unsigned addition of both the instruction. So let us do a simple addition instruction. So what I will do is I will take an instruction move A, comma hash 03H. So this is one instruction where A will be moved, the data will be moved to A. Then move R0, comma hash 04H. Now if I want to add both of it, what I will do is I will use the add instruction, add A, comma R0, and after this instruction happens, what you will see is A will be equal to 07H. So you can use various variants of that using any of these combinations. This is a very simple example using this instruction. So now we'll look at what are the kind of addition that you can do. Now the basic addition that you can do is an unsigned addition. So let us take a very simple example. So the previous example I will take. I am adding 03 and 04. So basically you are adding 0, 0, 0, 0, 0, 0, 1, 1 and 0, 0, 0, 0, 0, 1, 0, 0. So 1, 0, 0, 0. Now if I add both of it, so 1, 1, 1, here this is 1, this is 1 0 0 0 0 0. So here you can see the carry will be 0, and this is not used in unsigned addition. So the final answer is 07. Now let us see a number which is more than 8 bits. So let us add two numbers. So for 8 bit, that means 2 raised to 8 is equal to, it can handle up to 255. Now let us add two numbers which can be more than that. So let us say I take a number 200 and I take a number 100, and if we do a decimal addition, what you will get is 300. Now if I do a binary, so I do a binary conversion, so this is 128, 64 will be 128 plus 192, 192 plus 0 plus 8, 0 0 0 0, and this is 0 1 64, 64 plus 32, 96, 0 4. So this is the two numbers. Now let us add it together. So this is 0 0 1 1 0 1. Now this is carry, 1 plus 1 is 2, so you have 1 0, so this will give 0 1. Then this is 1 plus 1 is again 2, that is 1 0. This is the carry. So what you can see at the end is this carry will be forwarded. When the carry is set, that means there is an overflow, so an unsigned overflow. This is kind of the 9th bit, so this has to be saved. If you remove this number, what you will see is that you will not see this number 300. What you will get is 32 plus 8 plus 4, that is 12. 12 plus 32 is 44. So if you take this number, this is showing as 44, while the actual number is 300. So this bit will compensate for the overflow, and you need to save this. So this is part of the answer. The carry bit is the 9th bit. This is the 0, and this you can see is the 9th bit or D8. So you need to handle this carry bit to ensure that the number that you get finally is the actual number. Now let us look at some of the signed addition. Before going through the signed addition, I hope you should know the 2's complement and the 1's complement and understand the minimum basics of signed addition. Let us look at the signed addition. So let us look at a number which is easily carried. So let us look at FF. So this is in hex. In decimal, this FF in 2's complement form is nothing but minus 01. And then you have 1B, and this is 27. 1B is nothing but 16 plus 11, that is 27. And finally, if we add it together, we know we should get the answer 26. So this is what we should get, right? Decimal wise, we know what is the number that we should get, and maybe also hexadecimal, if you convert it, what you should get is the answer 1A. So let us convert it. 1 1 1 1 1 1 1 1, and this is 0 0 0 1, and 11 is nothing but 8 plus 0 plus 3, and 8 plus 3, so it's 11. So this is the number that you will get. Now let us add it together. So you can add 1 1 0 and 1, so you will get a 1 0, so you will get a 1, again a 1, and again a 0 again. Now please understand this, you will get 1, you will get a 0, and there is a carry. So you can see that when you add, there is always a 1. So I'll just make it simple. So add it 1 1 0 1, addition over here, a carry. So you can see this is 3, so there is again a carry. There is 1 1 0 1 0, there is again a carry. 1 1 1, so there is a carry over here. So 1 1 and 1, you will get a 1 over here, and there is a carry. So 1 0 1, this is a carry, 1 0, and you can see 1 plus 1 add over here, 0, there is 1 carry over here, right? So after adding 1 and 1, you will get this, and there is a carry over here. Now try to understand, there was a carry from D6 to to D7, right? When I did it over here, there was a carry. So 1 plus 1 is 0. So there you can see a carry. And finally, you can see from D7, there is also a carry. So from D7 also there is a carry. The final answer is 0, 0, 1 and 1A. So here you have a positive number. So by looking at the MS, we know that it's a positive number. And this number is 1A. That is what we have actually calculated before. So this answer is right. Now how to handle this carry? Now what will happen to the overflow and the carry? Now if you see, there is an overflow from D6 to D7. And if there is an overflow from D7 to carry. Now when both are there, that means there is no overflow. So that means there is no overflow. So this number is fit within the 8 bits. So you will see that this is equal to 0 and you can actually discard this. The carry does not make any sense over here. Let us look at another number. So we will look at a number called as 64H, that is 100, 64H and 32H. 64H is nothing but 100 and this is 50. So we have got 150. Now as we know, in a 8-bit signed number addition, we have minus 128 to 127. You can clearly see it's exceeding our number. So what we require is 96H, we will not get. So let us write the binary account of 64. So that is 0, 1, 1, 0 and 0, 1, 0, 0. Now let us look at the binary of 32 is 0, 0, 1, 1 and 0, 0, 1, 0. Now let us add it up together. So this is 0, this is 1, this is 1, this is 0, this is 1 and this now is 0, 1, 0. So we have 1 over here. Again you have an overflow 0 to 1 and 1. Now what you can see over here is there is an overflow. So there is D6 to D7. Automatically this overflow is on. There is no D7 to carry. There is no overflow. So what you will see is the overflow flag will be set. And what you can see over here is we would have required the number 96. So what you will get is the number 96 over here. So 96 is nothing but 106. So if you take the 2's complement, that means it is 1 as minus 106, which is not the number that we want. That is 150. So there is some problem of having a overflow number. So by looking at the overflow number, what we can understand is there is a problem with the sign bit. What we require is a positive number 150, but what we are getting is a negative number. As we know, for a signed number, when the MSB is 1, that means it's a negative number. So it's what we are getting is 96, which is a negative number, which is wrong. Here the overflow flag can be handled like a carry. You need to complement D7. So you make D7 as 0 and finally you need to take care of the carry. We can get an indication that there is an overflow. We can handle it in the program. Let us look at a simple number which does not overflow a positive number. So let us look at 03 and 04 again in the signed addition again. So what you get should be 07. So what we will see is 0, 0, 0, 0, 0, 0, 1, 1, 0, 0, 0, 0, 0, 1, 0, 0. And if I add it together, so now what you can see is there is no overflow. Carry will be 0 and overflow will be 0. In all the three cases, the first one is I am adding a negative number and a positive number, and if it does not overflow or it fits within our range of minus 128 to 127, we don't have a problem. Again, but the problem comes in when the range is exceeded, right? So 150, what you can see is that D7 gets set and what you get is a number which is negative. So instead of getting 150, what we get is minus 107. 6. Let us look at the negative numbers. Does it work in the case of two numbers which exceed the negative limit? So let us look at two numbers, that is E2, that is nothing but minus 30, and let us look at CE, that is nothing but minus 50. We can see that this is a minus 80, which is again within the limit of minus 128 to 127. So it is within this limit. So here we don't have any problem. E2 is nothing but E is 1110 0010. Then you have C is 1100 and E 1110, right? So this is the binary equivalent. Now I will do a basic addition. So you have 0 0 0, 1 1 is 0 1, I'll add it. 1 1 is 0 1, I'll add it. 1 1 0 1, so you have 1. Here we have 1. Now try to understand this. When I add D6 and this bit, I have an overflow. So you will see there is an overflow from D6 to D7. So I'll write it down. D6 to D7, there is an overflow 1. And when I add all these three together, so there is an overflow 1. So 1 1 1. So we have 3, 1 plus 1 plus 1, 3. 3 means 1 and 1. So there is carry. So there is an overflow from D7 to carry. When this both happens, both the overflow is there, that means overflow is 0. If only one of them is there, so only D6 to D7 is there or D7 to carry is there, then overflow will be equal to 1. Let us see whether we get the number. So when we look at the D7, one thing is it's a negative number. And finally, what you will see is this is nothing but, so add it together. So this is B11, B0. Okay, so the number is B0, which is actually, if you see and calculate and if you take the 2 complement, that is nothing but minus 80. What you can see is this number clearly is equal to minus 80 and we don't have to take care of this carry or the overflow. Since no overflow has happened, that means it is within the range. Now let us take two number which exceeds minus 128. Let us take a number minus 70 and another number minus 70. Then we add it, so we will get minus 140. Now as we can see, this clearly exceeds the range of minus 120 and let us see what happens. So we have this nothing but B A. So B is nothing but 1 0 1 1 1 0 1 1 and A is 1 0 1 0. The other one also the same way, 1 0 1 1 1 0 1 0. Now let us see the answer. 0 0 0 1 1 1 2, that means 0 and 1. We have over here 1 1 0 1 3 3 means there is a 1 over here again in 4. So there is 3 1 and we have add 1. So we have a 1 over here. There is no overflow from D6 to D7, but in D7 there is an overflow. So 0 0 1 and you can see the carry over here. Now clearly there is an overflow from D7 to carry. There is no overflow from D6 to D7. Now in this case overflow will be equal to 1. Overflow will be 1. Look at D7. D7 is 0. That means it's a positive number. But we clearly know this is a negative number we should get. The carry has been set and the overflow back will be set. When you get this overflow, that means you need to negate and add minus 128 to it and you will get the final value. This is what happens with signed addition. Overflow flag will be only set when there is a carry from D6 to D7 or D7 to carry. One of this at one point of time, not both. So this is how you can have a signed addition. So these are the basic instructions that you will see with respect to addition statement. Happy learning. and thank you.